Hello, everyone. Am I audible to you?
Yes,
Okay. So, in the last session, we discussed about NumPy, right? Now, in this video, we are going to discuss, in this session, basically, we are going to discuss about Pandas library, which is must for data analysis. Okay. Before we begin, if you have any questions to ask, then you can go ahead. All right. So, let's begin. So again, if you wanted to use Pandas library, you have to complete the installation. So Pandas is basically powerful open source data analysis and manipulation library. When it says data analysis and data manipulation is you can make analysis on the data that you have selected, and if you wanted to still manipulate your data, or you wanted to make some changes in the data, maybe deleting some stuff or adding new content in it, everything is possible using Pandas. Pandas works on two data structures. First is series, second is data frame. To work with the data, you have to create any one of them. It depends on which type of a data you are selecting. If suppose you have a data which is in the 1D format, it means directly a single 1D array, then you have to go with the data structure series. When you are dealing with rows, columns, or you have complete Excel sheet, you have complete CSV sheets, then you have to go with the data frame. Every time you have to create a data frame with that particular data. Okay. So data structures are important. Both of them are important. It is not like if you moving onwards, you will be working on Excel sheet, CSV files. So you need not to learn series. No, it is not like that. You have to learn series because sometimes for testing purpose or for training purpose, we have to create 1D arrays. We have to generate some samples, and then we have to operate on those samples to make our analysis more effective. So now let's begin with the pandas one. Okay, so I'm just creating day.ipynb. Pip install pandas because we wanted to use pandas library. Now, once this library is installed, you have to import this library. Again, if you wanted to import the library, you can also give it a nickname. So import pandas as, let's say, PD, which is the short form pandas. Okay. Now let's talk about the first core data structure of pandas, which is series. Series is one dimensional array. It can hold any data type, and you can also assign some indexes. So let's say S is equal to PD dot series. Okay. Now over here, I wanted to create a series of these numbers. When I'm creating a series of numbers, I'm writing it within the square bracket because there are more parameters that can be added in this same line. So you can see first is the data that I'm providing. Second is the indexes you can assign if there is anything none or hashable or you wanted to assign data types. More features you can keep on adding, more parameters you can keep on pass, but those are optional ones. So it is not mandatory that you add them. So let's suppose if I'm just going to write this much and I will just print the S variable. So this is our 1D array where we have these numbers, and along with the numbers, these are the indexes. 0, 1, 2, 3 are the indexes. If you wanted to change the indexes and you want the indexes of your own type, then what you can do is you can simply write down the indexes. Make sure when you are writing the indexing, you are focusing on the number of elements. So in our case, we are creating a series of four numbers. It means indexing should also be four. If you are going to write something less than that, then you will encounter some errors. Now I have written four values and then I am giving the indexes for three. So it shows value error saying that length of value four doesn't matches the length of index. So both should match. If you have made these kind of mistakes, you will get these errors. So now you will get the series with A, B, C, D as the indexes. Any question on this? Next that we have is the data frame. When it is data frame, it means we are talking about tabular data structure like a spreadsheet where we have two-dimensional arrays. So you can also create data frames using dictionaries. You can use any data type to create data frames in pandas. For an example, let's say d is equal to pd dot data frame. Now notice over here in series S is capital, data frame D is capital and F is capital. So you have to write it in the same way. Now here we have to provide the data. Right now we are just starting with the data frame. It means we have to create some sample data, right? So it can be anything. You can create any data frame just like we have created dictionaries. Same way you can write over here as well. So before this also you can create, let's say I'm writing di is equal to curly brackets name and I'm going to just write some names. So I've created a simple dictionary. Then I'm going to pass the same dictionary in the data frame because now I want that particular dictionary to act as a data frame in Pandas library. And then then I'm just going to print it for now. So now this data has been passed to the Pandas library and the Pandas library has converted it into data frame. And here we have the data frame. These are two columns and these are the rows. Any question in this? You can also assign the indexes in this also. So same way you have to just go over there, add comma, then let's say index is equal to, and then we have to write down the indexes. So initially by default your indexes will be 0, 1, 2, 3. If you want something else, let's say data 1, comma, data 2, comma, data 3. So then your indexes will be data 1, data 2, data 3. So that's how you have to change the indexes. Now let's talk about if I have the data already. Every time you need not to create the data. Pandas library is used because it has all the built-in functions and you need not to write separately to calculate anything, right? So what you can simply do is you have to first download one data set from anywhere online you can go and you can download the data. Now, when it comes to data sets, for sample data sets, you cannot take everywhere, like if you're extracting, let's say, you cannot go for that data because that data needs to be public data. You only have to download public data. Is there any question up till this?
No.
Okay. So simply what you can do is for downloading the data, you can use the Kaggle website. I'm just going to share another window. Okay, so you have to go to the Google and you have to search for Kaggle. And on the Kaggle website, you will get all the public data sets. Over here, you can see the data sets and you can download whichever you need. Now, when it comes to selecting the data sets for your projects, you have to understand which type of data you wanted to get, what you are trying to achieve, what you are trying to create. Okay. According to your interest, like right now, you're not working under any internship, you're not working for any specific company or anything related to this. So you have to go with your interest or your future goal. Suppose one person is interested in finance, so you have to go for the finance related data sets. Or if you are interested in e-commerce, you can go for the e-commerce. Or if you are currently working in healthcare, go for the healthcare data sets. And then you simply have to download it from this website. There are many more resources for dataset, but this is the more reliable one. So you can, let's say I'm just going to download this one. So now you can simply use this download button to download the data. So now the data has been downloaded. What you have to do next is you have to take that data to the folder in which you are working. So obviously, if you are downloading it by default, your downloaded file will be in the downloads. You have to cut it from there and you have to paste it directly in this folder. Okay. So I think that file, that folder, that file which I have downloaded is in the zip file. So I'm just going to take the different one for now to just explain. Okay, let me just add it up in the folder. Okay. So I've taken this Disney movies.csv. So you also have to notice that which one you are trying to import. Okay. Let me just reshare everything. Okay. So now our file extension is .csv. .csv means comma separated file. If I'm going to open it in Notepad, every value in this file will be comma separated. So whenever you want to load the file, you first have to understand the file name. Once you know the file name and the extension, then accordingly you can import it. Now there are built-in methods to import the file. So you have to use pd.read, pd.read. Now you can see according to your file extension, you have to select. Suppose you wanted to read HTML file, you go with read underscore HTML. If you wanted to go with the CSV, you have to go with the read underscore CSV. Then you have to again open the bracket. The same thing, you have to paste the path over here. So this is my file. You can directly type the name of that file as well. So this is Disney movies.csv. Now I'm going to just say print df. Now when you will say print df, everything will be in the result. You can see this is the type of a data that I have. Okay. This is the data set which I have selected, which has movie titles, release date, gender, rating, total gross. Everything related to this data will appear over here once you are going to print it. But this is not the ideal way of printing the data for view. The ideal way to print the data for view is you have to use two more built-in functions. When you wanted to view the data from the top, you have to go with your variable dot head. Let me just increase. Okay. Your variable. So you can see my variable is df. So I'm using the df variable, df dot head. Df dot head will do what? Will print the first 5 rows of your data. When you wanted to view your data from the bottom side, then you have to just use the another function, which is tail. This will give you the last 5 rows of your data. So first 5 rows go with df.head, last 5 rows go with df.tail. Any question up till this? Now, when you wanted to get the information about the data that you have, so you can simply use another function like information in terms like, let's say you wanted to know the number of rows and number of columns that your data consists of. So you go with the shape method. Df.shape will give you the number of rows and number of columns. So in total, we have 579 rows and 6 columns. Now, when you wanted to print the data from one single column, you don't want entire data to be printed, then you have to go with the variable, which is your df dot, and then you can, uh, there are two ways basically. This is dot method, and another one is you have to go with the square one. Now, over here, you have to mention the column name. So you can see when I have added the quotation, it automatically will show you the columns. So when I'm saying df dot this, it will show you that particular column data along with the indexes. Okay, when you want multiple columns, then also you have to follow same method. But in this case, you have to go with one more square bracket because now you are trying to get more column data. So let's say, I need to check the name of the column. So let's say movie title. Yeah, I think we're not closing one bracket. Okay. So now this is the format in which you will get the data because now you are trying to get the data from two different columns. Any question in this? Now, when you wanted to delete anything from the data, let's say I wanted to delete one column, which is the rating column, which I feel is not required. So you can directly drop that column. So df.drop will help you in this case. So let's drop this MPPA rating one. Df.drop bracket MPPA. This is the column that I wanted to delete. And then you have to also mention the axis. Okay, so for now I'm writing axis 1. Now this is your updated data where you don't have that particular column. If suppose you, like whenever you try to delete everything from data, you have to be 110% sure that why you are deleting it. You should have the reason for that. Second thing is you should be aware that you are deleting it because you are directly making changes in the data set. And if you are making changes, maybe in future you need that same thing again and you cannot get it because you have dropped it. Okay. So better ways you go with another variable and keep a copy of it. df1 is equal to this. So now you are not making the direct impact in the original data, but now you have df1. And df1 will have your updated data where you don't have that particular column. So deleting data is not every time recommended because whenever we make analysis, we have to think of alternatives that you have to be specific. Let's suppose in this data, we have the data related to movies, right? So now there comes up a question that which type of analysis you wanted to make from this. Whether it is related to recommending movies to the users or whether it is related to checking that in 2020, like 1940, which movie was on top, what exactly you are trying to identify from this data. Then only accordingly you can change, delete it. Okay. Now let's say you wanted to delete a row. This is the way you can delete a column. But now when you wanted to delete row, so when you are deleting a column, your axis will be 1. When you are deleting a row, your axis will be 0. Same method. So I'm writing df1 is equal to df1 dot drop bracket. Now you have to mention which indexes you wanted to delete. Suppose I want to delete 576, comma. You have to mention the axis. Axis is equal to 0 because this time I'm using the same function but to delete this. Now you can see after 575, I don't have 576 because I have just dropped that particular row. Any question in this?
Why axis is 0?
Because we are going with the horizontal way. Because we are deleting the rows. When you are deleting the columns, then you have to go with the axis is equal to 1.
If I don't mention any axis,
So then it will maybe it totally depends which version you are using. Okay, so let's say I'm deleting 577. Okay, so it totally depends how you are deleting it. Okay, so generally, like in cases of small data sets, right? It is bit easier for pandas to work on and go line by line and go to that particular index and delete it. But when you're specifying the axis, it becomes more specific for the library to work on and will give you the quick results. Okay.
okay.
What do you think? When should we drop any column?
When there is null value,
When there is null. Okay. How much null? Like 5, 10. Suppose there is a data set in which there are 5 null values in one column and the data set consists of 1 lakh rows. What should we do? Do we need to drop the column?
we can drop or fill. We can, I don't know.
Yes. So it totally depends. How many null values do you have? First thing. Whenever it comes to the point that you have to drop something, right? Whenever you have analyzed, okay, these are the features of your data sets, these are the number of rows, this type of data type you have in the data set. After that, you have to think of irrelevant features. When it comes to irrelevant features, it means you have to go to your outcome, that what exactly you are expecting in the outcome. If your outcome is related to finance and you have the data related to product description, let's say, or product details, let's say, or reviews or comments, then in finance analysis, these features are not required. So you can simply drop those irrelevant features because these columns are not going to contribute to the analysis or your target prediction that you're going to make with the data. So first you have to go with the irrelevant features and then you simply have to drop them without thinking anything because you are going to make the changes in the copy of the data. You're not making the changes directly in the data. Okay. Second thing is when you have high missing data percentage. High, it means if the missing percentage is above 60 or above 70. Like most probably go with the 70, but in some cases we go with the 60 plus also. So when a column has too many missing values, or you can say imputation is not possible, then at that time you have to delete that column. Okay. Another dropping scenario can be like, let's say there is a table, there is a data set in which you have one column which is related to, let's say, gender. Male, female has been mentioned over here. First way is you just directly convert male, female into numerical data, 0 and 1. It will be more easy for you to making analysis. Okay. Now let's say there are two different columns. One is for male, another one is for female. In me male column, everywhere it is mentioned male, 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 male. And in female column, wherever it was female, it is mentioned, and other times it is just null. So in this case, there is a low variance. It means your data is not varying row by row. So column with the consistence or near so columns which are not consistent basically, which are having just some fixed values, maybe one value or two value, then it means that column consists of some constants or near some constant. Near some constants values means they just have two or three values. Then first option that you have is you convert that data into numerical data using 1 and 0 and 1, or else you drop that because it is going to provide very little information and it is going to just give you 0.1% impact in your analysis. So rather than making that a main feature, just go and delete it. Okay. You can also drop some duplicate columns if you have any. Like let's say you have a data set in which you have three different columns: first name, last name, and then full name. So you can simply delete either full name or you can delete first and last name because you already have full name. So better option is go with deleting full name. Got it? Any question in this? Yeah, anyone? Any question? Okay, now let's talk about the next type of function. Now let's say you have two different data sets. Data set 1 and 2 both are important for your analysis. So at that time, what you have to do is you have to merge your data sets. Merging your data sets again have two methods. One is using concat function, another one is using merge function. With concat function, you have to mention how you wanted to merge them, and concat them. And when you're going with the merge function, you also have to mention a common column. Okay. So pd dot concat, then you will mention your data frames, comma, then you have to mention the axis. And this way you can concatenate two data. Okay. Now you can see how many rows in total you have, but you still have six columns, which are the common columns. Okay. Now, if I am going to write x's is equal to 1 and I'm going to just run this, now you can see now we have more number of columns and the same number of rows. When I was writing x's is equal to 0, then we were just getting the double of the rows that we have right now. So that's how x's impacts on your data. And that's how you can concatenate two different data sets. When it comes to merge, there is one more method of joining two data, which is merge. When you're going with merge, you have to mention first is you have to mention the data frames. So first is let's say df and then second is df1. Df and df1 is not having any common column. So merging is possible only if you have something in common. It can be anything in common. Let's say there are two different tables, but movie title is same in both the tables. Movie title is the one column which is available in both the data sets. Then you have to do what? You have to write down movie title over here. Over here, you have to mention the movie title as a column, which is the common column between both the tables. And then you can easily merge. Any question in this? Now, let's say I want to filter my data on the basis of certain criteria, or you can say on the basis of some conditions. So I have to, you can use like, I'm going to create one more new variable for the filter data. So df3 is the variable, and I'm going to apply the function on df. Now df is my original data from df. Now where your condition is, for which particular column your condition is. So let's say my condition is for, do we have anything numerical value? Yeah, I think we can go with this total gross one. Total gross is greater than, let's say, how many digits does it have? So this is the data, which is our filtered data. Wherever the total gross value is greater than this, we are getting that data printed on our screen. So that's how you have to filter the data. For filtering the data, you just have to follow the syntax, that is from the data set, from the entire data sets, and then I am applying the condition. Now here you have to notice the square brackets, because square brackets plays a major role in this. When we are going with the columns, you have to use square brackets. Okay, so df, then the column name, and then the operator using which you have to apply the filter, and then the value.
Why to df?
One is for entire data, because this is from data I'm applying the
Okay, okay.
the
This is the condition.
yeah, for entire data I'm applying the condition for, and for applying the condition I'm using one of the data df. Okay. So filtering is bit easy. When you wanted to just filter the data based upon the condition, you can go with this. Now let's say you wanted to add a new column in it. Adding new column is very, very simple. It is just you have to use df, which is our initial data set variable. So let's say df, let's say new column is equal to. Now this will give us some error because we are trying to give the wrong length. Okay. So when you have the data which is with the same number of values, then you can simply add this particular column. Got it? So adding column, dropping column, or getting some information about the column. Then we also have one more function, which is df.info. Df.info will give you the information about your data. It shows that, okay, which type of a data you have. Okay, you have now it in the data frame. Then what is the range index? So this is the range index. It starts from 0 and ends up to 578. And in total, there are 579 entries. Then it shows data column, how many total number of data column it has. Then column name showing non-null count and dtype. Non-null count means basically it's going to show you how many non-null values are there. So wherever you are getting this 579, it means that column consists of zero null value. But if like in this MPAA rating, we have this 523 or 562 or 579, sorry, yeah, these two only. So these two columns have null values. This also shows you the data type. So just in the beginning of Python, I told you that those data type which we have learned, which is string, integer, float, are just for the basic understanding of the data structures or data types. In Pandas, we have the data type object. Object means string. Object is similar to string. Then we have int 64. It means integer with the 64 bits. And then in the total also, it will show you how many object column you have and how many integer values you have. Integer value or string value. So there are four columns which have in string values, and there are two columns which have integer value. And how many, what is the memory usage of this particular data set? Then that also shows you within the info. We also have one function which is called describe. Df.describe is going to show you some statistical analysis of your data. That what is the total number of count. Let me just add it up in the print. Yeah. So now we have the total number of counts, which is 579 it was supposed to be. And then the mean value, standard deviation, minimum value, and then 25% value, 50%, 75, and max value. Everything you can get at once with the describe function. Got it? Any question in this?
Hello? Yeah. In this info, I mean, how do you check the total number of null value and the percentage of null value? Let's say in 2 and 3, January and MPEPA rating.
Yes. So for now, I have this info function is going to just give you the overview of everything, right?
Yep.
That how many, like what is the non-null value and all. So what you can do next is you can use some more functions to identify a missing value. Okay. There are two different types of missing values. Whether in that particular columns, data cell, you will get NA or you will get null as a value written over there. Okay. So you have to use the functions called is NA and is null. Okay. So df dot is NA will give you the data in the true and false format. Wherever the null value is, it will add a true at that place, or if you have no null values, then it will add the false. Okay. But this is not the effective way of viewing it. You have to target the particular column. Okay. So let's say my column is January 1. Okay. So I'm going to add up and then is any. Again, it will give you the values in the true and false. You can simply add a sum over here and it will give you the total number of values where NA is present. Okay. Also, to make it more accurate, or you can go with the is null also. So wherever the null value is, it will show you that value. It is considered as an NA or null, then only it will present. If suppose there is an incorrect data present, incorrect means let's say in MPA rating and rating was supposed to be G or E or something, and some characters has been mentioned which is totally out of context. So that won't be uh, counted in this particular function. So this function is just going to count the main NA and null values. Got it? So, like right now in this data, if I give you the example of just Disney one only, so you can see we don't have more, like it is just, I think, above 80% of data we already have. Only just in some cases, there is 20% of missing data, or in some cases, maybe there is 10% of missing data or 5% of missing data. So you can simply impute some values in this case. To impute the values, you can go with the mode value from the entire data, which is like frequently occurring. Then you can add that data value at the missing value in the place of missing value. Okay. That's how you have to work on this data sets. All right. Now, your today's task is that you have to practice the data, pandas library, and then you have to take one data set from Kaggle, and then you have to try to get some information from the data set, and also you have to get ready with the analysis, the type of analysis that you wanted to make. Okay. And then you have to start with going ahead with the missing values and handling it up.